Okay. Again, if you still had questions from the other stuff, we can work through it. Oh, I'll take it. That's fine. Thanks. We can still work through that today because you guys are asking really great questions. Okay, so this is the last part of how to name ionic compounds. And it's not going to be too much more difficult than what we've done. It's just adding on a little bit of extra thing at the end of it. Okay? So some ionic compounds, they exist as hydrates. So what does hydrate mean when you think of hydrate? Water. You think of drinking water or something like that. Hydrating yourself, yeah. So hydrated compounds actually have water molecules attached. Okay, so they're attached. So it doesn't mean that they're dissolved in water or anything. They're still solids at room temperature, right? Because all ionic compounds are what? All ionic compounds are what? Liquid, gas, or solid? Solid at room temperature. Oh, do you guys have blanks? Okay. So some ionic compounds exist as hydrates. That's your first blank, right? Yeah. What's the next blank?
It's have water molecules attached.
Have water molecules attached. Thank you.
Then we don't got it.
Like it's all filled in.
Yeah.
Okay, great. Thanks. Okay. So yeah, like I said, it's not that they're dissolved in water, but they actually exist as an ionic compound, as a solid, with like a water molecule attached to it, which is kind of crazy to think about it, because it's like, well, water is supposed to be liquid at room temperature, right? But as a part of this compound, it's actually a solid. You want to see an example of one? Yeah. Oh, man, you guys are so excited. I'll show you some. You've actually seen it already before. Okay. See? Copper. Don't sniff it though, right? That's the one.
You gotta walk it.
Yeah.
What happened?
Well, Josh smelled it.
No, I was wafting it.
Yeah, just a lot maybe. Too much wafting.
Well, it says do not smell.
Okay, so this is copper 2 sulfate, and then it has a 5 hydrate. But what is it? Is this thing liquid? No, definitely not. It's at room temperature. It's a solid. It's very blue. Often things with copper, like copper 2, copper 1, will be blue or bluish green. When you burn things with copper, it makes a really blue or a green flame. You know those things, those packages you can put into a fire to make it all pretty colors and stuff? There will be definitely copper shavings and stuff in there, because when you burn copper metal, it will be blue. Yeah. And so copper solutions, compounds or solutions with copper will have blue or greenish kind of things. Copper ions. So this is an example of copper 2 sulfate pentahydrate, it's called. Okay. So this is the type of naming that we often use, is like this, nickel 2 sulfate hexahydrate or whatever. Now, I'm going to be doing more prefixes with you guys next week, but I need to tell you about prefixes today. So kind of on the side or something, write 1 to 10. So write a list 1 to 10. We'll do this more next week too, but. And I'll tell you what each prefix is. Yeah, lots of you already know some of them. So number 1, mono. 2 is di. 3, tri. 4, huh? Quad? No, well, quad means 4 as well, but in chemistry we use tetra. 5 is penta.
I think 6 is hexa.
Yep, 6 is hexa. 7 is hepta. Yeah. Now 8 is octa. 9, nona. Yeah. Octa. And 10 is deca. Good.
Can 2 also be like pi?
Pardon me?
Or 2, can it be like pi as well?
Yeah, in other words, like binomial, bi means 2, but for naming compounds we just use di. But you're right, bi in other contexts also means 2. Okay, so let's try some of these together. Okay, so you name the ionic compound the same, and then you just add the prefix with hydrate at the end. Okay, so this part, we're just going to name it the same as we've been learning, and then this part is just added on at the end with the prefix and hydrate. Okay, so we're literally just adding something on to the end of what we've done. Yes?
Why is the sulfate
Because it can either be pH or F.
Okay.
Either is fine. Yeah. Okay, so let's convert this name into a compound. Now, when you're converting, always, always, always write what? Ions. Always write out your ions. So copper 2 is Cu2+. What is sulfate? Where do I find that? The polyatomic ions, yeah, SO4 2-. So SO4 2-. So when I crisscross, since they're the same numbers to crisscross, I can just write it as Cu SO4. And deca, what did deca mean? 10. So then I just go, I put a dot, and then I go 10 H2O. So the dot just kind of separates, saying that it's kind of the water's been attached on. Okay, any questions on that example?
So when we're doing this is iron.
Go ahead.
No.
Okay. So let's try the next one. So sodium carbonate, we just name like normal. So sodium is Na+, carbonate. All right, so that kind of sounds weird. That's not carbon, so that means I need to look at my polyatomic ions. So carbonate is what? CO3 2-. So you crisscross the numbers that are with the ion. So then I get Na2, good, CO3, dot, oh, does yours say deca? Did I change it on yours? Pardon?
It says penta.
Oh, sorry. Yours says penta. Okay. So penta means 5. So then we go 5 H2O.
Why do you put brackets around like the 4 and the 3?
Like here?
Yeah.
How do I know not to put brackets?
Yeah.
Okay, so the only time you need to put brackets is if your number applies to more than one letter. So, or one element, sorry. So like here, this 2 came down here. Well, that only applies to one element. This 1 came down and it applies to the whole thing, but since it's 1, I don't have to put it in bracket. Do you want me to show you an example of when we would? Okay. So say I have, so Michaela just wants clarification on a question, so I'll just do another little demo, okay? So say I have calcium nitrate, okay? So calcium is Ca2+, and nitrate is NO3-, right? Okay, so when I crisscross these, this 2 comes down here, and this 1 goes down here. So I end up with Ca1, bracket, NO3, close bracket, 2. Because this 2 had to apply to this whole thing.
Okay, it doesn't just apply to the oxygen.
If it has to, yeah, it doesn't just apply to the oxygen, it applies to the whole polyatomic ion. Yeah. Okay, so we'll go back. All right, so now we have to go and do it into a name now. Now even, pardon?
Need to uncrisscross.
Yes, we need to uncrisscross. So that means we still always have to write out our ions. And I know sometimes you think it doesn't matter, but because we know now that there can be multiple types of ions, we need to still write it out. So barium was Ba2+, and chlorine is minus. So then you look at barium. Can barium be more than one ion? No, so that's fine. I don't have to write in my Roman numerals then. You see that? So then the name is just barium chloride dihydrate. Barium chloride. Pardon? Okay. Ready for the next one?
Yeah.
Yeah? Okay. So, sodium, so Na is for sodium. The SO4, that's SO4 2-. So that gives me the compound sodium sulfate decahydrate. Sodium sulfate decahydrate. Yeah, and as was brought up before, it's correct to do sulfates with both an F or a pH. It's, I don't know, American versus Canadian or something. I don't know what the difference. Okay, ready for the next one? So Li is Li plus. ClO4, go to your polyatomic ions. ClO4 minus. So then you get the compound lithium. What is that? ClO4. Perchlorate. Whoa. Lithium perchlorate. Right?
Yep.
Yep. Was somebody asking me something?
No, I said try.
Oh, trihydrate, yeah. Trihydrate. Okay. And the last one, Zn.
It said 0.
Oh. I must have not, I missed one at the end? You guys have another? Okay.
Yeah, number 7.
Okay. And SO4 2 minus. So this is zinc sulfate heptahydrate.
Should we have been writing in Roman numerals for something?
Only if there's multiple options.
Oh, okay.
So when we look at zinc, which I should have been talking about earlier. So zinc, can it have more than one ion? No, so that's how you know
Yeah.
that you don't have to. Okay, what's your last one?
Cobalt 2 chloride hydrate.
Is it like the name or is
It's
it
like the words.
the words cobalt 2?
Chloride.
And what's the end?
Dehydrated.
Oh, like D-I.
Well, it's DE in our page.
D-E?
Yeah.
Oh, maybe I meant D-I. Dihydrate?
Me?
That would make way more sense. Because either it's deca or di. Okay, so cobalt. So it specifically told us cobalt 2 because cobalt has more than one option. And chloride, there's only ever one option for that. And di means 2, and then the hydrate. So when we put this into a compound then, I'd crisscross, and I get COCl2 dot 2H2O. Okay, so now take out your workbooks and I'll explain the next word. So now what you can do is page number 7 is just hydrates. But then what I want you to do after you're done page 7, and lots of you have already started it, is now you can do all of page 6 because now, like page 6 was like a mix of lots of different types of ionic compounds.
I did all pages.
Good, okay. So do page 6 and 7 if you haven't done page 6. Alright? Yeah. I'll just turn off my video.